When the organizer contacted me to give this talk, I have to confess I really had mixed feelings. So, as and I said, MRI Together is for me my kind of spiritual home. Uh, I started this adventure with some colleagues that became also amazing friends, and this started in 2021. And these people are here. I still took this from the MRI Together page. These are Laura and Sanam, Emma, and Maxim. So they also gave me the title Open Science in MRI, What is Missing? And I was really hesitant to take it because, on the one hand, this is my home turf. And on the other hand, I didn't want to sound like the old rambling grandfather cursing at the clouds. So, on the other hand, however, then I thought I checked my Spotify, and Spotify reminded me that my age, my musical age, is 64. So maybe the role of grumpy old grandfather actually suits me. And then, if people know me, they also know that I like to complain a lot. So for sure, you will enjoy listening to me rambling for the next 45 minutes. To be honest, I'm not totally sure how long this presentation will be. We will see. Anyway, I'm kidding. I hope I will not complain too much. I have been accused, and this is actually for you, Shahan. I know that you will listen to this talk at some point. I've been accused of being preachy, and today I will definitely be preachy. I like being passionate about things, and I like trying to have people see it my own way. And so I really embrace this preachiness, and I want to imagine you this talk as a song. You can imagine maybe this is a love song to research, and specifically my research. I've been in this field for 20 years, so I would say I'm right in the middle. I still hope that I have a long road ahead of me, but I've also had the pleasure of seeing this field evolve in many ways, and of course, most of them were positive. So this is somehow a love song. I love research. Somehow I love academia, although I'm like every love relationship, it's always a bit of love hate. The system of academia is so unnerving at times. But as every good song, this song will have a refrain. And our refrain today will be, when a measure becomes a target, it's easy to be a good measure. And you might know this. This is called Goodhart's law. And the second part of the refrain is, don't lose sight of the real goal. So keep this in mind for the rest of this talk. And this is the home base that we'll try to continue to go back to. So let's start with some definitions. I was originally asked to give this talk as Open Science, What is Missing? And I asked the organizer to kindly change the title to Open and Reproducible Science, What is Missing? Uh, Open science and reproducible science are two concepts that are intimately related to each other, but they're not quite the same thing. And open science are all the practices that create a scientific endeavor accessible and transparent. So you can think of open source software, open data, open access publications. So this is usually important for reproducibility, but they are not the only aspect. Reproducible science, instead, are all the practices that, on the other hand, make a paper reproducible. So this is the famous Manifesto for Reproducible Science. And as you can see here in this indication of threats and solution to reproducible science, open methods are not really mentioned. So they are not necessarily related to the availability of the methods and of the code. Rather, when we talk about reproducibility or reproducible science, we are more talking about planning of a study, analysis, interpretation, and dissemination of the results. So if one uses some code to obtain the results, one can still have a reproducible paper without the code being open. So we don't have to release the code as open source. You can put instructions on how to replicate the results using, for example, commercial software. And this is actually a route that is foreseen by the RSNA journal. So if you look at radiology guidelines, for example, they say that they encourage software to be open source. But if it's not, you can just say, I've used this commercial package. So if you're testing a commercial package, as long as it's accessible to other people and they can use it the same way you did, then it can still be reproducible science without being open science. So there are many definitions of reproducibility, and you might have heard of computational reproducibility, repeatability, replicability, and of course, each of these definition has a reason to be, and uh, they, of course, focus on important aspects. But um, if one starts defining these aspects with bullet points, so what I have to do for computational reproducibility, what does I have to do for repeatability, and blah blah blah, then reproducible science becomes a checklist. So it's correct, it's important in some cases, but let's play our refrain now for the first time. So when a measure becomes a target, it ceases to be a good measure, and we should not lose sight of the real goal. Reproducible science should not be a set of bullet points that we have to fulfill one by one. We have to understand what it actually means. So the seminal paper that started the reproducibility crisis did not even use reproducible in the title. This was the paper by John Ioannidis in 2005, and he went straight to the point. He was saying most published research findings are false. So we don't care about reproducibility, actually. So we are here talking about reproducibility, but we don't really care about that. We want something that is true before it being reproducible. It's just that reproducibility is a way in which we can hope that what we are publishing is actually true. So I want to adopt my own definition of reproducibility. And the definition is that if someone runs my study again, they will reach conclusions that are compatible with mine. And this seems trivial, but it implies a few things. First of all, that one can rerun the same study again. And this is the concept of open science. If I don't tell in my paper or in everything that comes with my paper how I run the study, this cannot be rerun. It implies that my results derive from my acquired data. So if someone else acquires similar data, they will be able to do the analysis the same way as I did them. So this means I have to avoid questionable research practices, such as elimination of outliers without the prior justification, p-hacking, and even selective publishing. So if I run my study 10 times and I only publish the one time that the study gave me a significant result, then this is also not deriving the results from the acquired data, because I acquired actually 10 times the data than what I publish. And then it also implies that my conclusions are the correct interpretation of my results. So when you write your conclusions, you have to acknowledge that there is some variability. Another person that runs a similar study on different data that they acquire, they might not have the same results as me, but as long as I acknowledge that my results fall within a bell curve of p-values or of probability, and acknowledge that there are confidence intervals, then a repeated study might have results that still fall in the confidence interval of my own study. So it's important that I don't present my study as the final truth, but acknowledge that everything happens on a spectrum. So this is the way of designing a study that not only reproducible, but is also contributing to give a correct representation of the underlying truth. So in science, it's really unlikely that we reach a definite truth, but we can always approximate with better and better probability what the truth is. Okay, this is the definition of reproducible science. We have seen open science, what it means. Of course, there is much more to say about both these aspects, but um, we can start now talking about what is missing. So the title of the talk is "What is Missing." Let's talk about that. So to understand what is missing, of course, we also need to understand what has been done so far. And I have to say, we have come a long way in the last few years. Maybe not in the last few years. This is something that has been a long time coming. I think the Reproducible Research Study Group of ISMRM has been established, yeah, probably around 10 years ago. And so some practices that were considered niche then and for the last years, they're becoming much more mainstream. So um, uh, to actually have some quantitative feeling of this, I ran a PubMed search for open science and open data in MRI. And I want to share the results because these are the results for the last 25 years. So it's starting in 2000 in the year 2000 to 2005. So open source has increased constantly in the proportion of papers. So these are not absolute papers. This is the proportion of all the papers published. And it's interesting to see that in MRI has tracked the general trend until 2016, more or less, where it started to increase and surpass the average of the medical field. However, it is still below 1% of all published paper, but this also contains all clinical journals, etc. So it's not necessarily a terrible thing that open source is less than 1% overall. So this is everything involving MRI and everything involving medicine in general. So MRI is doing actually better than the average. Open data is somehow similar in a way, but here we are tracking a bit behind the general average. But again, we see that the gap is closing, and in the last year, the gap is virtually closed with the average of the medical field. So this is also reflected in our community. And MRI Together is a clear example of this. It started in 2021, and it's been successful since. But the open reproducible science has gone beyond MRI Together, and this was absolutely amazing to see. There was hardly anything of the sort in ISMRM and the ESMRMB in the previous years. And this year we've had ISMRM plenaries dedicated to open science. Actually, to the specific case of open source acquisition, reconstruction, and hardware. The ESMRMB conference this year had the hot topic debate dedicated to open science with the provocative title "Only Open Science is True Science." I hope you followed it at the ESMRMB. That was really fun. And other initiatives. Magma had an MRI Together special issue on open science, and also at the same time a special issue on reproducibility. These we put them together last year, and they were published this year. MRM started a code review initiative that is going really well. It is on a voluntary basis. If your paper comes with accompanying code, you can opt in for this code review facility so that volunteer reviewers will also check whether the code works as intended and if they can run it on their machine if they can use it. So, and if this is the case, then you can add to your paper an acknowledgement that says that the code has been checked. So it gives an extra credibility to your paper. This was born from an idea by Krishna Nayak and was brought forward by the Reproducible Research Study Group. And this was definitely something that was enthusiastically accepted by the MRM board, and it was, yeah, there have been quite a few papers with the code reviewed. So definitely something that enhances open science and reproducibility. 23, 24, the SMRM challenge was about reproducibility. And it also had the requirement of study pre-registration. So it was a reproduction of a study and also the aspect of pre-registration there. This challenge was the brainchild of Laura Bortolotti, Maria Eugenia Caligiuri, and Sophie Schaumann. And from this was born also a very important initiative. But now it's time to make a digression. So now we've seen what have been achieved, and now let's blur a little bit the lines about what is there and what is missing. In 2022, this was the summer after the first MRI Together. I was really in the peak of reproducibility. It was still a topic that was emerging more and more. And in 2022, before MRI Together, a lot of the focus was more on open science and specifically on open source tools and open source software as tools for producing reproducible science more than reproducibility itself. And in 2022, I wrote this thread on Twitter, and I called it as Fish in the Water, Why Method Development Research Has a Huge Publication Bias Problem. But nobody sees it. In this thread, I argued that method development research is actually hypothesis driven. So we consider our field, and a lot of us, probably most of us, are developing new methods. And we're looking at the other fields like psychology, where the reproducibility crisis was born, and we were looking at them saying, okay, this doesn't really happen to us because they have a reproducibility problem, but because they're doing hypothesis testing, and then they can do p-hacking, they can do data manipulation. But as we don't need to do a proper study. We don't need many subjects because a method, either it works or it doesn't work. And here, instead, I argue that it was definitely not the case, because when I develop a new method, then I want to use some objective metric and try to demonstrate that my new method is better than another one. So it might involve statistics or it might not, but in any case, I still have the hypothesis that my method is better than the other one. And then if I try something and it doesn't work, then it's kind of guaranteed that I have no chance to publish it. It goes to the drawer. No one wants to publish failed methods. And this is the mantra that a lot of people mention to me. So a failed method, so a method that doesn't demonstrate to be better than another method, goes into the drawer. So we have all seen this plot. This is from, let's say, classical medical research, where you do statistical analysis, and you see that these are all the these are z-scores, but they're basically p-values. These are all the published studies, and basically what you see is that all studies that are published are outside the non-significant zone. Very, very few studies are published in this zone where the results are non-significant. But actually, they should be many more. And the missing part in the middle are all the studies that would counterpoint the positive results. For every positive result, there might be a negative result that was never published. And so, if something goes well once, it will be published because it will fall outside this non significant zone. But then it will lack all the context of maybe the 10 times that this experiment has failed. So, how does this apply to our field? So, for us, it's hard to pinpoint easy statistical tests. We don't have simple tests. We usually rely on different metrics. Sometimes they're qualitative, sometimes they're semi-quantitative, sometimes they're fully quantitative, but it's hard to make such a plot. But we are still only publishing the methods that end up fulfilling these metrics. So only the methods that end up looking better than existing methods end up getting published. And this is by design. So this is overinflating small and underpowered studies that happen to show a positive result. Producing a good, robust method is hard. And it's much easier to work on 10 small projects and then publish the one or ones that end up working. Okay, so this is the hypothesis somehow that I have and the theory that I have. But of course, you have to say, is it really a problem? Is it hurting our field, and how well is our field really doing? So let's go back to our reframe. When a measure becomes a target, it ceases to become a good measure. And don't lose sight of the real goal. What do we do as researchers? What are we told that we have to do since we are in PhD students? We produce papers, and we are judged by the number of papers that we produce. And this is the first metric. So we pursue maximization of papers. And then someone figured out that this is not enough. Someone said, well, we don't just want people to write papers. These papers must have an impact, because they realized if you just maximize the number of papers, then you just maximize the amount of rubbish. So these papers must have an impact. So as good quantitative researchers, what is the impact? The metric change from just writing papers to counting citations to these papers. So a paper with many citations, for sure, it's something that made an impact. But is it really so? So we want to make an impact. Our real goal is to make an impact. And what do we want to achieve? So actually, it's not papers, it's not citations. These are only metrics that we might want to use to try to infer the real impact. But we want to make a difference in the real world. This is why we are here. We are not here to write papers. We are here to discover something or to produce something that helps in medical diagnosis, helps the end user. So otherwise, why are we doing it? So just for this talk, I ran a small study. I took 18 papers from 2022. So 2022, I gave it enough time to actually accumulate a few citations. So each of these papers describes a new method. I don't want to get into fights. If people want to know what these papers are and the methodology, they can contact me afterwards. But at the moment, I'm just presenting the results. It's not reproducible, I know, but it can be. I just don't want people to say, but my paper was blah, blah. So 18 papers, they had 156 citations. It's not bad. It's a median of 8 citations per paper over 3 years. It's absolutely not bad. So impactful paper. So what are these citations? Only 7% of citations were other papers that were using the described method. Actually, one single paper was used 8 times, and this kind of skewed this result. And only 2.6% of the citations were building up upon the method. So taking this method and making it better, or using it as a reference to mention that I made a better method, but I also tried this other method. 90% of the citations were like this. Bulk citations in another paper added to the dreaded literature review. No, you put literature review and said these other people also did something similar, but my thing is different. But it really had no real impact on the actual work that was done in the study. So the median of the number of citations that built upon the original method was 0. So most of the papers were never built upon. The median of citations that uses the method was 0. So most of the papers were never used again. So is this really the impact? So when you develop a new method, is it really your hope that it will end up in a bulk citation in another paper at some point in the future to boost your H index? Is this what academia is really about? Is this really the impact that matters? This is what we want to ask ourselves. So some other statistics. 3 out of 18 released the code open source. This is more or less in line with other papers in the previous years. The median sample size was 8, and it was a little better than what had been found previously. In a bigger study before, they found a median sample size of 6. However, remember that with a sample size of 8, if you are, for example, estimating a standard deviation, a sample size of 8 can give you an error in your estimate of up to 100%. So if you find a standard deviation of 2, and standard deviation is usually related to noise and to variability, so we use standard deviations a lot. But if you only have 8 subjects, your standard deviation can be double what you actually find. Can also be half. So you have a very big margin of error in the estimation of your standard deviation. So a sample size of 8 is nearly not enough to do any meaningful characterization of a new method. So this happens in our field. We said that we want methods that work. We don't want methods that don't work. And it does seem reasonable. We do not want to publish methods that don't work, because a method that doesn't work is considered noise, no? And we want to maximize our signal to noise in our literature. So we want to select only the methods that work. We don't want to publish methods that don't work. But is it really true? So even PLOS One, and this is kind of related to what we were saying before, PLOS One is a journal that is very supportive of open science. And even PLOS One says that a method can be published only if it's demonstrated that it's better than another method. So PLOS One has built in this publication bias inside its own guidelines. So it seems to think non-working is noise, working means valuable signal. But is a working method by these standards really signal? So MRM publishes 400 papers per year. Magma publishes 50 papers per year. It's safe to say that more than 500 MRI methodological papers are published each year. And we have seen that 90% of these methods will never be used again. So is it really a good thing? Are we really selecting the signal in our pile? So we're told that papers are the sign of good research, and working methods make good papers. But have we lost track of the goal? Go back to our refrain. When a measure becomes a target, it's easy to be a good measure. And we should not lose sight of the goal. In 2022, I was already indicating that register reports, pre-registration, and so mostly register report were a potential solution to this problem. I think that by now you should all be familiar with the register reports. Finally, they have become an object of discussion. This transition between reproducibility being limited to open methods into really more holistic view of reproducibility in our field really has made register reports center of the discussion. But in a nutshell, you describe the study that you intend to run, and then you submit this description to a journal. And then this gets peer reviewed. You get feedback from reviewers, and you can go back and forth like a normal paper, but you haven't run the study yet. If this gets accepted, you get to publish the results, regardless on whether this is positive or negative. So if you plan a good study, even if the result is negative, it will get published. And the idea is that we should have fewer and more powerful studies that validate proposed methods. So the idea of having this in a method development environment is that not only you give a proof of concept, but you also plan a proper validation so that you don't have 1,000 tiny methods that might or might not work because the validation study is definitely insufficient. You have fewer methods, but with rigorous validation that will give us strong and reliable results. So if a method fails this validation, you will have done it with enough power to actually be sure that you were not just unlucky because you tried it on a couple of people and you couldn't make it work. You had an idea that might have worked, but then in the long run, when you really try on a big cohort, it doesn't give uh, the results. And this is valuable information because someone else can take this method, see what is wrong with it, or it can say, okay, this was an approach that might have been tried and actually didn't end up not working. Um, At the time, we tried proposing register reports to MRM. I've talked about it in the past. That proposal failed spectacularly. The board of MRM was absolutely against it. People are saying, yeah, you want to publish rubbish methods that don't work. They failed to see that publishing a method that doesn't withstand a rigorous validation might be worse than publishing 1,000 methods that are wonkily validated. But anyway, fortunately, the good news is that something is moving, and the fact that I don't have to explain to you in detail what a register report is a sign of this. So register reports are now a reality in both ISMRM and the ESMRMB. And this is definitely thanks to effort of a growing group of motivated people. This was born from the challenge. Maria Eugenia, Laura, and Sophie really spearheaded this initiative in ISMRM. Myself, Patricia Clement, and Joanna Vannecher brought this initiative also in the ESMRMB. So I would say that it will definitely be repeated in next year. It started this year in both conferences. It will happen next year in both conferences again, with slightly different modalities, but the core concept is the same. And this is fantastic, but it's the beginning because the proper registry report format only makes sense in a journal context. So a conference is a good start, but it has to be a journal because with a journal, you can get proper reviewer feedback after stage 1, and then you get journal acceptance, so it becomes a paper. And the paper has a different weight than a conference proceeding. But mostly it's this initial part where you can adjust your study based on the feedback of the reviewer to make sure that the power is enough and is correct. Okay, so things are moving and we're on the right path. So is this all? Are register reports the last piece of the puzzle that is missing to make our MRI truly open and reproducible? Brian Nosek from the Open Science Foundation uses this graph to show the stages of transformation of the scientific landscape. And as you can see, it's a multi-leveled approach. And where are we now? So finally, I think where we are now, we have created a solid infrastructure for open and reproducible science. As I mentioned, I wish to see register report implemented in journals, but we are definitely on the right track. In some cases, we're also making it easy. We have constructed code review. It's easy to get something accepted in conferences, in journals, because we have sessions, the issues dedicated to the topic. Is it becoming the norm? So are we breaking the third level. Well, maybe not strictly in our field, but in the broader scientific community, open science practices are definitely becoming more popular. The Swiss funding body, where I'm in Switzerland, so I get money from the Swiss funding body, and they define a model of excellence that explicitly mentions open methods. So, an excellent study is something that has an open method and also collaborative behavior. So, this is quite amazing that SNF will fund excellent research, and excellent research is defined by these characteristics. So we're getting there. One missing piece of the puzzle, and I mention it because it's a talk about missing things, but it will be explored in other sessions in MRI Together, is data sharing. It's still very complicated from technical side, but mostly from regulatory side. This is a big topic for another day. It's still a missing part, and I really wish it was more mainstream. We have seen that slowly MRI is closing the gap with the rest of the medical field, but when we talk about open data, especially in the context of AI, just being a small percentage of all the papers published is not enough. But anyway, I just mentioned this, but it's not the core tenet of my talk today. So in the end, we have seen that we are on the right track. Open and reproducible science is uh, coming, has come, it's already there, it has become more and more important. But does it matter? Open and reproducible science practices are important, but they're still instruments to what we want to do. So they're not the goal. Remember the reframe. When a measure becomes a target, it's easy to be a good measure. We don't want open reproducible practices to be the metric by which we judge our research, because otherwise it becomes a checklist. And then if you tick all the boxes, then you think that you're doing good research. But these are an instrument. These are a way in which you can reach good research, but it's not a sufficient way. We should not strive to write papers that are open and reproducible. The real goal is that we want to produce research that is relevant and useful. And this is up to us as authors and as reviewers. So we are doing research ourselves and we are being peer reviews. When we write or we review a paper, we should ask ourselves, why does this need to be said? Is this increasing the knowledge on a subject, or is it giving actionable information that others can build upon? Or is just presenting something that the researcher did but has no ultimate influence in the research that comes next? And implementing open reproducible science practices is often a necessary condition because we want to make technically good research, but it's not the sufficient condition. And this is something that when I review a paper, I always ask myself. A paper ultimately is an announcement that we make to the community, and we say, this is what I have found. But if the community cannot do anything with it, specifically if I make a method that I claim is working for me, but I'm not releasing this method openly so that others can use it or the others can build upon it, why do I need to tell the community that I did that? The paper is not for the researcher, the paper is supposed to be for the community. And I think we have lost sight of this goal. And we can try to find ways to justify why certain papers should be published, but the core goal is that we want to make research that increases the knowledge that the community has and increases the tools that our doctors have to actually treat patients better. So, my final message to you is remember that open reproducible practices are a necessary condition, but they're not the goal of our endeavor. And we are making sure that we do not lose sight of the real goal. Thank you very much.